Hello everyone, welcome back to Ampnics. In this video, we are going to discuss something really exciting. Nowadays, everyone is using AI tools for their daily life tasks. Being an electronics engineer, I wonder can we electronics engineer also use these AI tools for writing the firmware or developing the hardware or developing a complete product? So the answer is not pretty straightforward. In this video, I'm gonna design a Gen AI based timer board using DeepSeek AI tool and KiCad for automating heavy loads. Basically, a lot of time I plug my EV bike on charge and I just forget about it. So this board is going to cut down the power when my bike will get fully charged. So let's get started. The user interface of DeepSeek AI is very minimalistic and it is very simple and it is just like other AI tools. So here you can put your message or we can call it prompt. So I have already written my prompts. So what I will do, I will copy my prompt, okay, and I will paste it here. So my prompt is very simple. I want to design a Gen AI, basically Gen AI, Google Home, Siri or Alexa, IoT based timer board for 220 volt slash 110 volt AC up to 30 ampere with manual time setting for free. So when I say IoT devices, so for cloud you need to pay, but we want to make it for free. So let's see how DeepSeek is going to help us for building a hardware. Well, setting it for free is not our part, but still we are concerned about that. We want to know like how DeepSeek is going to guide us for this. Okay, so we got the answer here, and we will look into this. So designing a Gen AI powered IoT timer board for 220 volt 110 volt AC up to 30 ampere with manual time setting requires careful planning for safety, functionality and cost effectiveness. Exactly. It is considering the most important parameters: safety, functionality and cost effectiveness. Exactly. Below is a free DIY approach using open source tools and affordable components. Okay, let's see what are the components. So system overview, voice control over Google Assistant, Alexa or Siri, okay, via HomeKit. Manual control, physical button and display for time setting. Exactly. Relay control, 30 ampere relay for switching AC loads. Yes, that's correct. IoT connectivity, Wi-Fi or Bluetooth, ESP32. That's 100% correct. That's 100% correct. Safety, overcurrent protection and isolation. Yeah, we can use that. If I talk about the system overview, as per our requirement, it is 85 to 90% correct. And I will tell you what is missing here, although most of the important parameters are already considered here. So if I see the component requirements, so it is taking the ESP32 as a main controller, okay, and for programming it we need ESP IDF or like Arduino. You can use Arduino IDE also for writing the firmware. And relay module, okay, you can use relay up to which is for 30 ampere, or you can use solid state relay also. So we are going to use electromechanical relay, but this suggestion is also great. Okay, then current sensor, okay, which is fine. Like if you want to sense the current of the load, so we can use the current sensor as well. And for display, OLED display, yes, OLED display consumes less energy, so we can use OLED display. Buttons and rotary encoder. So yes, tactile switches. Exactly, we need a power supply, 5 volt buck converter or ESP32. Yeah, so for instead of buck converter we are going to use something different, I will tell you. And for enclosure, so as you can see, like it is suggesting each and every component. Like it is telling us about the microcontroller, the relay, the current sensor, display, buttons, power supply and enclosure, which means it begins from the firmware side to hardware to a CAD modeling. So basically it is taking all the parameters. So you can see this is the potential of AI. This is the potential of AI tools. You can use it in your projects also. So let's see the circuit diagram. So 220 volt AC to 30 ampere relay load. Okay, this is correct. Current sensor, that current sensor will send the data to ESP32. Yeah, that's correct. And ESP32 is additionally connected with the OLED display with buttons. Okay, and this microcontroller is also connected with the Wi-Fi. All right, so I can say yes, this circuit diagram is 100% correct. We are going to follow this block diagram only, and it is also telling us about like the wiring steps. So you can see like in AC side, in control side, everything is there. What I will do, I will share this project over Hexter.io, so you can check my project over there. So in last video I designed a complete IoT based air quality monitoring system with KiCad and Grok. If you want to check that video, I will put the link in the description. You can check that video and you can see the like how Grok AI can help us for building the hardware. So you will find all the respective files over GitHub. Also you will get the circuit diagram and everything over GitHub also. So this is like a software setting also, which I'm not interested as of now. This was like very general prompt. For that reason it was giving us a generalized idea to build this system. Okay, so when I give the proper prompt that I want to use this device and I want to use this instead of this, so let's see at that time what is the response of DeepSeek. So this time I want to design it with the following components: ESP32, and I will put here electromechanical relay, electromechanical electromechanical relay, high link power supply to 20 volt to 5 volt DC, 4 push button for setting up the time manually, EMS 117, I2C port for display, buzzer and LED for feedback. So these are the following components, and I will type here one more thing. So we have another response from DeepSeek. Great, you have well-defined component list. I will help you to design PCB in KiCad with proper block diagram and circuit connections for your Gen AI IoT timer board. So basically, when you give the proper prompt to AI tools, they will give you better response on the basis of your prompt. Because when you give the generalized prompt, they will consider everything. So this time I provided the relevant information about our project, so that's why it is giving the response according to this prompt. So if I talk about the system block diagram now, so here we have 220 volt AC, then that 220 volt AC is connected with the high link power supply, which is correct because we are going to get the 220 volt from here, then we will feed that 220 volt power supply into 5 volt DC, and that 5 volt DC is connected with the LDO, which is converting this 5 volt DC into 3.3 volt DC, and our ESP32 works on 3.3 volt. For that reason we need this LDO. And further the relay is also connected with the 220 volt AC on the load side, and for IO side it is connected with ESP32, which is 100% correct, you can see here like it is perfect, it is perfectly explained. Then on ESP32 IO side, I2C display port for OLED or LCD display for push button, buzzer and status LED for feedback. So you can see like this block diagram is perfectly explained. So in KiCad PCB design steps, there are steps for designing the PCB also. So number 1A, it is schematic design. In schematic design we need to design first power supply. Okay, so first we need to add high link, then AMS, then ESP32. Okay, which is correct. Okay, 1 ampere fuse before high link for safety. Okay, relay control, ESP32, BC547. Okay, this is perfect, man. You can see like it is telling us about every detail, like you have to use a transistor, you have to use a diode, you have to use an optocoupler for providing the isolation. This is perfect. Then user interface for push button, I2C display. This is we already given to the data. So buzzer, status LED, and safety features are also there. Like we can use 30 ampere fuse and MOB for transient or like any surge protection. I can say like this is the perfectly explained schematic overview. I can say like we can follow this one only. Then for layout, place the high link and AMS near the AC input. Exactly, this is perfect. This is good. Keep high voltage 220 volt track thick up to 2 mm. Well, now I'm like I are really amazed with the response of DeepSeek AI. Like in last video I used Grok AI, but I can say like the response of DeepSeek is better than the Grok AI, and isolated from the low voltage. Yes, that's perfect. Route relay traces separately high current. Place buttons near the edge for accessibility. Yes, it is telling us about the placement of the component as well. Add screw mounting hole for enclosure fitting. Yes, that's correct. Anyways, let's jump into the KiCad. So here we have designed our schematic. If you don't know how to design the schematic and PCB in KiCad, make sure to check this playlist, how to KiCad. I have attached the link of this playlist in the description. If you are interested in designing the PCBs in KiCad, you can check this out. Basically, in this playlist, I have explained the complex topics in a simpler way. If you see here, like I have arranged the components in a blockwise manner. You can see power supply, relay, setup buttons, feedback buzzer, display, programming pins, microcontroller, and isolation. So well organized schematics are easy to read. So I will begin it from power supply. Here we have our main power supply, which is getting 220 volt as a input, and it is providing us 5 volt and 3.3 volt. So for getting 3.3 volt, we are using here AMS 1117. Alright. So 220 volt into 5 volt, 5 volt into 3.3 volt. Along with this, I have added a comment also. So you can read this also. Then we have a relay. Here we have added a optocoupler for providing the isolation, which was already mentioned by the DeepSeek. And along with that, we have added a NPN transistor also. And for feedback, we have added a LED. And as we know, like the electromechanical relay comes with the inductor coil or a copper loop. For that reason, we need to add a diode, which we call it flyback diode or freewheel diode. And further, the switching side is already connected with the load. N stand for neutral and P stand for phase. And here we have added a net load underscore phase. So this is the simple circuit of relay. Then further, we have setup buttons. So I added the setup buttons for setting the manual timings, so that you can set the time with these buttons and you can write according to your use. For that reason, I have used 4 buttons. Then further, we have added a isolation. What is this isolation and what is this 0 ohm resistor? Why it is so important? This is very much important for hardware level debugging. If you want to check like this block is working or not, you can just remove it. Or if you want to just measure the current, how much current this block is consuming, you can use the multimeter or ammeter on this 0 ohm resistor. So in this way, you can easily debug the hardware. So for that reason, I have added everywhere for buzzer, for microcontroller and for display. And still, if you have any doubt, make sure to join our technical community chat over WhatsApp. The link is in the description. Further, we have feedback buzzer. So this buzzer will turn on for a couple of seconds so that we can know that our device is on or off. Along with this buzzer, we have added a LED too. So we can see that our device is online or offline. Or you can use this LED for debugging also. So it is kind of optional feature. And further, we have programming pin. In this project, we didn't design the onboard programmer for programming the microcontroller. We are going to utilize this UART pin RX and TX. Then further we have added a display connector. Basically display works on I2C protocol, so for that reason we have added a connector here, and a decoupling capacitor is also placed with this for avoiding the noise. Then we have our main microcontroller, which is ESP32. So this is a very simple schematic. I don't think so this is complex, but if you have any problem or any doubt, make sure to comment it below. So now what I will do, I will validate my schematic. Is it correct or not? Basically, we are going to use this DeepSeek AI tool for reviewing our schematic. So we will upload our schematic PDF into it. Okay, so we have added the PDF of our schematic, and I have written a prompt here, review this schematic for above project. So let's check out the review of our schematic design, which we uploaded the PDF file. Okay, so number one, power supply section, good but needs minor fixes. Okay, correctly step down to 20 volt to 5 volt, then 3.3 volt to for ESP. Okay, this is perfect. What are the issues? Missing input fuse, and C4 10 microfarad should be placed closer to AMS 1117, and MOV, add a MOV. So basically this input fuse and this MOV, I didn't connected it intentionally. So DeepSeek is suggesting us to use this part in the project. So I didn't use it intentionally, so we are not going to consider it here. And this C4, which I already kept 10 microfarad capacitor near to our voltage regulator or our LDO. You can see here, like we have added three capacitors, like this is at the output of our this 5 volt of high link power supply. Then we have like in the input of our this LDO, and then output of this LDO also. So this is not true, so this is not a issue. So here you can see like we got zero issues. Then after that, in relay circuit, critical fixes needed. What are the critical fixes? Uses MMBT 2222A transistor for switching. Yeah, we are using this transistor for switching the relay. Then what are the issues? Missing flyback diode. Add a 1N4007 across the relay coil to prevent back EMF damage. Okay, so it is suggesting us to use a PN junction diode as a flyback diode. Okay, well, if you see our schematic design, so you will find that we have already used a flyback diode, SS4, which is a Schottky diode. I don't know why DeepSeek ignored this, but this is not true. So this is not the issue. Relay trace must be thick or greater than 2 mm. I didn't ask for the layout suggestion, but it is saying us right now. So this is not true. Then optocoupler is unused. Okay, we already used the optocoupler in the schematic design. You can see here, like we have used it here, but it is saying that we didn't use it. So in relay section we got zero issues. Then after that, user interface mostly good. Correct pull down resistor, well, that's not a pull down resistor, that's a pull up resistor. But it may be possible that DeepSeek got confused, like I connected it with MCU 3.3 volt instead of directly this 3.3 volt net. So we can consider it like uh, this AI tool may got tricked with that net. Anyways, so this is not the issue. Then it is suggesting us to use a debounce capacitor along with the switches for cleaner signals. Yeah, it is good suggestion. Then for I2C display properly labeled, okay, suggestion, add a pull-up resistor 4.7K. Yes, it's a great suggestion. But why I didn't used in our schematic? Because we are going to use the module. So in module, there's no requirement of a pull-up resistor. For that reason, I didn't used it. Then after that, we have buzzer connect via transistor Q2. What is the issue? R16 0 ohm is unnecessary. Okay, let me check where is R16. So Okay, there's no R16 here, R14 is there. And for isolation I kept R17. So I don't know why it is taking the display isolation here. So as you can see, like DeepSeek isn't able to review this parameter at this point. Then for ESP32 wiring mostly correct. Okay, GPIOs are well assigned. What are the issues? IO0 boot mode pin is connected with the switch one. Ensure it doesn't interfere with programming. Yeah, it's true. So that button I used for keeping the microcontroller for boot mode. So for that reason we use that switch. Then UART, TXD and RXD pins are unconnected. Well, it is not. We have connected a pin there. Like you can see, this header pin is connected with the RXD and TXD pin of our microcontroller. So that's not a true. So here what I can say, like you cannot rely on AI tools 100%. You should have some fundamental knowledge of electronics. Otherwise you will fail to design a successful project or a product. So you might getting a question like then how we can use it in our project and how we can utilize these AI tools for designing the projects or making our life easy. Well, there's only one thing so far. You cannot rely on it 100%. If you are taking some reference, if you want to do some calculation, then you can check it. But although I will suggest, like if you are using the AI tools for designing the hardware, then make sure to always double check the system or like whatever the information you are gathering from the AI tools. Anyways, let's go for the layout design and check for layout suggestion. So I have already written a prompt here, and I will copy this and I will paste it here. For layout designing in this project, I am considering 0.3 mm, 0.5 mm, 1 mm, 2 mm of tracks. Okay, I will remove this 1 mm. I don't need 1 mm. 1 mm, 2 mm, and 3 mm of tracks. 0.3, 0.2 mm track for connecting passive components. 0.5 mm for 5 volt and 3.3 volt 1 mm. Well, we are going to provide 2 mm for high link power supply and 3 mm for connecting the loads with exposed mask layer. Okay, so I will tell you what is exposed mask layer in layout section also. But the response on this track designing, your track width strategy is mostly correct but needs slight adjustment for optimal current handling, safety and manufacturability. Below is the refined approach. Okay, let's see. Number one, track width recommendation based on current and voltage. Okay, so for signal traces 0.3 mm, 1 OZ, safe for low current signals. Yes, this is true. 3.3 volt and 5 volt. This 0.5 mm is correct and adequate for 500 milliamps of current. Adding zero point 0.1 decoupling capacitor near to ICs. Yes, we are going to use it. Then for high link 2 mm and ensure the keep zero point 0.5 mm clearance from LV. Yeah, this is great suggestion actually. Like we need to keep the clearance. Okay. Then for 30 ampere load relay output, 3 mm exposed copper with solder mask opening for extra current capacity. Yes, exactly. So like I don't know where's the slight adjustment. It is following our same data which I entered in the prompt. So I'm not interested in the other part, but I will keep this chat in the description so you can read it by yourself. Also I will share some screenshots so you can read it by yourself. So I'm gonna design the layout on the basis of this data. As you can see, like we have designed the whole layout with the same track sizes 0.3 mm, 5 mm, 1, 2 and 3. Well, I didn't used anywhere 1 mm. I just kept it. I don't know why. Okay, so we used this 4.3, 0.5, 2 and 3 mm. So here for playing safe side, we used 3 mm track. So if I click it, and you can see here, like, see, this is about 3 mm. All right. And for this high link, so you can see this is about 2 mm. All right. So, and if you notice one thing here, that we didn't pour the copper here. Why so? Because this is our AC signals, and rest of the part of this are like low voltage signal. So it may be possible that it will cause the EMI and EMC issues. So for that reason we didn't pour the copper here. Okay. Then let me turn on the 3D viewer so you will understand it better. Okay. So if you see here, basically what I did, I had created a cutout. So in the relay section and in the high link section, this high link cutout is not necessary, but I did it for my own convenience. If you don't want to do it, yes, you can. And for here it is required, because this relay is switching the high voltage devices or and high current devices. So for that reason you are driving this relay from 5 volt. So for that you need to make a isolation here. So that what I exactly did here. Okay. So if you see here, like we have created the exposed track also. So if we want to increase the current handling capacity for this track, so we can add more metal, or like we can add more copper wire into it by soldering. This way we have designed this high voltage tracks. And for here, like for 5 volt and for 3.3 volt, we have utilized the 0.5 mm. Okay. So you can see this is like 0.5 mm. And for these signals, so this is about 0.3 mm. All right. So in this way we designed our layout. We have already completed the layout and the placement of component, schematic, everything is done. Let's ask for the review to our this board. So what I'm gonna do, I'm gonna take a screenshot of our component placement, and we will ask for reviewing our placement. Okay. So okay, what are the placements? Okay, let's check the response of DeepSeek on it. Relay placement, key specification. Okay. Placement recommendation: place the relay 10 mm away from the low voltage. Yes, it is already kept 10 away, 10 mm, like more than 10 mm. Okay. For thermal management, avoid placing under ESP32. Yes, yes, exactly. So we already kept, like if you see here, like this is far away from our relay. So you can see here, like we already consider those things. We already kept our the decoupling capacitor near to our microcontroller, and like everything is away from the relay. All right. And you can see it here also, like when I shown you the tracks also, like you can see the like the clearance is a lot. I mean, it is more than 5 mm. So it is not going to cause any error or like any issue here. So let's check the final checklist here. So relay isolated from low voltage, yes, we did it. High link close to AC input, yes, we did it. With slot cut, yeah, we already did it. 3 mm exposed traces for relay output, yeah, we did it. Short I to C bus traces with no AC crossover, yes, exactly, like there's no AC. You can see here like our I to C signals are here, and AC signals are here, like which is like it is away from these I to C buses. Okay. Then silk screen level for high voltage warning. Okay, this is like we can add some high voltage warnings in our PCB, since we got no space in our PCB. So I don't think so uh, it is required. Basically we are going to use this in a 3D printed box. So I already attached some notation here: phase, neutral, load phase. So it will already determine like this is the high voltage. But if you want to do it, yes, you can add some those kinds of references. Let's ask for rating our PCB on a scale of 10. I will tell like okay, so the rating of our board is 9. Well, this was not expected. But anyways, why not 10? Even the perfect design can benefit from real world testing or minor irritative tweaks. Yeah, that's true. That's 100% true. So for this, like you can read it. I will attach the this information in the description. I don't want to make this video too long. So yeah, this rating is fine for me. There are some limitations of AI for designing the hardware, but yes, I have shown my best to representation of AI tools on behalf of hardware designing. So this was the video on using KiCad plus DeepSeek. If you found this video helpful, make sure to like the video and subscribe our channel for more technical content.